Oh, I didn't know that. Alright, today let's take a look at an ellipse. Our definition of an ellipse is the set of all points for which the sum of the distances to two fixed points is the same. Okay, so what that looks like, okay, is if I have two fixed points, okay, the easiest way to visualize this is if I take a string of the same length, right? So this is one piece of string that's attached down at two different points. And I just take my pencil, okay, and drag, maybe not, maybe I have to reload it. Maybe it doesn't work if I zoom in on it or something. I don't know. Maybe it just doesn't. There we go. Okay, so if I click and drag, okay, it creates an ellipse. Okay, so our definition of an ellipse is the set of all points where the sum of the distances from two fixed points is the same. Okay, so no matter what point I'm on this ellipse, if I were to add these two distances together, in this case it'll be 7.5, okay, but that's how we define an ellipse. Okay, so our definition of a parabola was all the points that are equidistant from a fixed line and a fixed point. Our definition of an ellipse is all of the points whose sum is constant, or the sum of the distances from two fixed points is constant. Alright? So, our standard equation for an ellipse that's centered at 0, 0 is this: x squared over a squared plus y squared over b squared. Okay? So, this equation gives us a lot of I guess we can draw our axes here. So we're saying that the center is at 0, 0. Okay? Whatever the denominator of this first fraction is, okay, if I take the square root of that, so the square root of a squared is just a, that gives me the distance from the center to each, we call these the vertices, okay? They're the endpoints of the major axis, okay? So there's a lot of vocab there, so let's label what's going on here, okay? So the endpoints here, we say these are both vertices. This then is called the major axis. Okay, the major axis is just whichever piece is longest. Okay, so in this one, this is going to be the major axis. Okay, in this one, this is going to be the major axis. Okay, so in this case, since my major axis is along the x-axis, this denominator tells me the distance from the center to the vertex. So this distance is going to be a. So if my center is at the point 0, 0, then this vertex is going to be at the point a0. Same thing going this way. This distance from the center to the vertex is a, so then this point here would be negative a. Denominator of y tells us how far then to go up and down. Right? So if I go a distance of b up and down, I will get to these endpoints here. So this would be at at 0, negative b, and this would be at 0, positive b. Okay, so these values here, or the square roots of these values here tell me how far to go from the center to get to each endpoint. Now, the longer axis is called the major axis, so in this case, the shorter axis is called the minor axis. These points then, okay, these are technically not called vertices. The endpoints of the minor axis here, we just call endpoints of minor axis. So we're going to abbreviate those endpoints of minor axis, so we don't have to write that out every time. Okay, EPMA. So EPMA is endpoint of minor axis, and then the vertices are the endpoints of the major axis. Right. So if we're not going to label all of that on this one. Okay, the only thing that would be different if my ellipse, the long side is vertical instead of horizontal, well, this would be the major axis, and this would be the minor axis. Okay, everything else would remain the same. Okay, these would still be a distance of A, these would still be a distance of B. Okay. Questions so far? So it says, note the longest length is always the major axis. Okay, I already mentioned that, but there's a place to put that here. The longest length is always major axis. And then we labeled it on the diagram up there, but the vertices, right? So the vertices can change depending on our orientation, right? The vertices are just the endpoints of the major axis and EPMA, how we're going to abbreviate the endpoints of the minor axis. Okay, so let's jump into an example then. So our first example here is the equation 9x squared plus 4y squared equals 36. So it's not quite in our standard form yet. Okay, to put this in standard form, I want my equation to be equal to 1. I want 1 to be on the right side. So I am going to just divide everything by whatever this value is. I'm going to divide both sides by 36. Okay, so when I do that, I get 9 over 36 here. So we just want to reduce that fraction. 9 over 36 would reduce to 1/4, right? So this would just be x squared over 4. 4 over 36 would reduce to 1/9. So this is just going to be plus y squared over 9, and then equals 1. Okay, so now we have this in the form that we want it to be in. So just from this equation, I can get a lot of information. Okay, my center, well, I guess first of all, we can answer whether this is going to be horizontal or vertical. How would I tell that? Just by looking at the equation. What do we think? Is the longer side going to be vertical or horizontal? How do you know?
Because the 9 is under the y.
Yeah, okay, the value under the y is bigger. So that tells me that the major axis is going to be along the y. Okay, so that means it's going to be longer vertically. Now, for these first few examples, our center, we're saying, is always at 0, 0. So now, from my center, how far do I need to go left or right? I'm going to go 2 to the left and to the right, okay? Because we're taking the square root of whatever value is under x, and that tells me how far to go in the x direction. So I'm going to go 2 to the left and 2 to the right. Then how far in the y direction? 3, right? The square root of 9 tells me I'm going to go up 3 and down 3, my center. So here is my ellipse. Okay, so to answer these next couple of questions, which is which? Right, the vertices, right, and it tells us are the major axis. So which one is the major axis in this case? The y. Yeah. So these 2 points will be the vertices. So 0, -3, and 0, 3. Then the endpoints of the minor axis are going to be these two. -2, 0, and 2, 0. So then the last part we haven't talked about yet, how to find where the 2 foci are. The foci, we're going to use, I'll write it up here. We're going to use this equation. Okay? A squared minus b squared equals c squared. Okay, now, I guess should mention that this can be flipped, okay, depending on which one's positive. Right? We just want to put the positive one as the larger one. Right? So we could actually also have b squared minus a squared equals c squared. We just want to put whichever one is positive first. Or I'm sorry, whichever one is larger first so that we get a positive value on the left side of the equation. Okay, so in this case, if I'm looking at my a squared and b squared values, I've got 9 and 4. So I would just take the larger one minus the smaller one. Okay, so in this case, I'm going to say 9 minus 5 equals, or I'm sorry, 9 minus 4 equals c squared. So then we'll get 5 equals c squared. Take the square root. We get that c is equal to the square root of 5. So what that tells me then, okay, the c value is the distance from the center to each focus. Now, the foci, I guess we can make a note of this as well, are always on the major axis. Okay, so I'm going to go a distance of the square root of 5 from my center along the major axis. So that would be right about here and right about here. So those are my 2 foci. Right? Square root of 5 is just a little bit more than 2. Right? So those 2 foci will end up here and here. So those 2 points then would be 0, negative square root of 5, and 0, positive square root of 5. Questions so far? All right, then let's try this example where we're given the vertex and the foci, and we need to find the equation. Alright, so again, sketching a picture is going to be a really good way to go. Now, actually, I guess for this, I should have put a space to put in our our standard equation with the vertex not at 0, 0, okay, because we're starting with a vertex at the point 5, 0. So our equation for an ellipse not centered at the origin, we just throw in our h and k. Right? So x minus h squared over a squared plus y minus k squared over b squared equals 1. Okay, so it's a really similar equation. We're just throwing in a place for an h and a k. So, for this example, we have an ellipse centered. Oh, it does say centered at the origin. Sorry. Centered at the origin. We'll use this in the next example then. With a vertex at 5, 0, and then foci at negative 4, 0, and 4, 0. Okay, so vertex, focus, focus, center. So I guess, first of all, they only give me one vertex. Where would my other vertex have to be? Negative 5, 0. Okay, so now I need to find how far up and down I need to go from my center to get to the endpoints of the minor axis. I know that this is the major axis because the foci are on that axis. Right? So I automatically know that this is going to be in the longest side. I'm going to use my equation, my a squared minus b squared equals c squared here. Right? So I know that this is going to be the longer side, so I'm going to put that in for A. So B is going to be smaller here. So the distance from the center to the vertex is 5. So I'm going to put this as 5. So 5 squared minus B squared equals, now C squared we said is the distance from the center to a foci, or to a focus. So that distance is 4. So this is going to be equals 4 squared. So we've got 25 minus b squared equals 16. Subtract the 25 over. Get negative b squared equals negative 9. So b squared equals 9. Which means b equals 3. So that tells me from my center, I'm going to go up 3 and down 3 to get to the end points of my minor axis. So now we still need to put all of this together into an equation as well. So my center is at 0, 0, so I'll just have x squared over the distance from the center to the vertex is 5. So 5 squared. And it doesn't matter if we write it as 5 squared or 25. Either way is fine. Then plus y squared over 3 squared is 9 equals 1. And so we can actually sketch this out then. So then to answer all these questions, center is at 0, 0. The vertices, which are the endpoints of the major axis, they already gave those, right? So negative 5, 0, and 5, 0. Endpoints of the minor axis would be 0, negative 3, means 0, positive 3. And then the foci, they already gave us those as well. Negative 4, 0, and 4, 0. Questions?